Hello again, it's Cliff here. So, building your own CNC stand or enclosure or monitor stand. You may have a background in CAD or CAM or electrical and not be familiar with fabricating, and so this series of videos is just to sort of give you a general introduction into it, and that it isn't that difficult, so that you can consider whether you want to do it for your own application. You can build a more compact stand, a more rigid stand, a more compact enclosure than the standard stock product, and I'll show you some of the tips and tricks along the way. Cheers. Well, here we are. We've got the new slider. So it's the next size up from this slider. This is a very compact enclosure, just 55 inches wide. And my other machine is a little bit more. So this is 410 millimeters and 810 extended. So that's more than adequate. Lovely smooth action slide. Seems to be a thicker grade of steel in the actual slider. It's a bit hard to measure because of the burrs and the angles, but I'm pretty sure it's a gauge thicker. I've done other videos on enclosure design, but I haven't gone into the details of the Slideway design, and it's really important, I think, that you have a bottom slideway that doesn't trap chips or swarth that eventually jam up and become an impedance to smooth sliding. You know, you get the sort of crunchy granola effect as bottom tracks jam up with swarth. And so one of the important considerations on this design is to have it sort of hanging free, so that any chips that do bounce down in that area and in the central area don't become congested with chips and swarth. And the other consideration is to have, as well as that, is to have it so that the coolant doesn't leak out. And I'll just set it up and show you that. Okay, well, let's simulate what happens with coolant flow as it comes down here and comes down here. Let's just use this to simulate it. Better put the coolant on. Okay, so you've got the coolant spraying down there and it's running off and down this sloping surface. And here again, spraying off and running back into the pan of the machine. So I'll get the camera now on the other side and show it again. Okay, well, let's just look at how this works. So this bottom lip is on quite a steep angle. It's not level, it's on a steep angle, so the coolant flows down, and there's a barrier vertical strip here that the door slides behind. So let's just show that. Shuts against that stop, and it slides on the inside of that barrier strip to the stop there in the middle. Well, it's important to have quite a bit of over design with these overlaps and slopes because of the properties of liquid, you know, capillary action and surface tension. It'll flow uphill for short periods if you don't have a generous amount of overlap. Let's just show that in operation. So we just simulate coolant flow up here. You can see it's sort of bubbling up around there, and if that was flush it would start dripping out. And then again here there's no problem because you've got it well and truly overlapped there. So with my conversion to sliding doors on the other Tormac 1100, I've put a fairly solid piece of angle iron as a bottom ledge, and wider than it needs to be, and mounted it on quite an angle, about a millimeter over 40 millimeters, tilting in towards the enclosure. And I'll silicon seal that eventually, and that should ensure I don't get any leaks. But it's a good idea to double check these things as you go, because you don't want to commit to a design that's going to leak. So it just takes a few minutes to lash something up. I put a bit of tape on there to simulate it being sealed with silicone. Put some parallels there to simulate the gap I'm likely to have. A little bit of an overlap there, and then I can apply some coolant. You can see it's running off the inside and not the outside. But there you can see it's bubbling back with the surface tension or the capillary action by a couple of millimeters. So you do actually need to have a generous overlap. So I'm making up the hardware, a couple of hours here and there, making up the odd bits and pieces for this door conversion. I think it's a good idea to make up the bits and pieces, you know, just in your spare time in between jobs. So that when you do come to do the major project, you know, welding and painting and so on, you've slimmed it down to a relatively small job, and it isn't so disruptive at that point. Here's the dimensions if you want to build something similar. They're just mild steel parts. I don't need to explain how to make these because most of you will be machinists. I realise it's possible that some of you may want to contact me and say, can you let us have a design so that we can copy your stand or an enclosure or so on. I would encourage a different approach. These current designs are not perfect because they're the result of a gradual evolution of improvements over the years. So I'd rather that you just looked at the videos, measured your particular machine, which is probably a different size, or the one you're planning to get, which is probably a different size than these 1100s, and actually finalize your own design, put together all the features that you want. Because the current designs are somewhat of a mix of the latest improvements and some legacy features that I've just lived with because it would be too much work to rebuild the whole machine. Hope you can follow the logic in that. If I was to now design, if I was commissioned to design the ultimate stand and enclosure and monitor stand, that would be a lot of work. It would be a lot of work, it would be a lot of fun, but I don't have the time for that luxury. Okay guys, cheers.